Thanks very much, Graham. Now I'm a little bit worried because what I just heard there was, this is the graveyard slot and don't say anything technical. So I'm in trouble here. And I can't make you any promises because there is some technical stuff in here, but hopefully it will be interesting. So yeah, I head up the international program at BGS. So what am I doing here talking to you about critical minerals in the Northeast? Well, critical minerals is very much my thing. I've been working on it for almost 30 years. I know I look too young to be doing that. And I want to give you a bit of information about what BGS is doing in this area and how it's relevant for here in the Northeast. And I should say I'm very much representing some colleagues. So Emma Didi is actually leading our UK critical minerals research. David Curry is working with her. And Alison Monaghan is our head of geothermal. She gave me some slides to put in here. I don't know much about geothermal. I was going to summarize them, but Jason Boddy has done it for me. So thanks very much, Jason, and I will go through those very, very quickly. So first of all, the British Geological Survey. Who are we? We are the world's oldest geological survey. We're coming up quite fast on 200 years. And we are the national data repository for all geological data. So you can access our National Geoscience Data Centre and attain pretty much all the information that is available. And we do research and acquire new data that underpins the provision of impartial, independent advice to the UK government and to a range of other stakeholders. Unlike many countries where the Geological Survey would be part of the government, we actually belong to UKRI, the UK's overarching research council, so it's an arm's-length body of government. And we are funded partly by them through the Natural Environment Research Council and partly by commissioned income that we tend to win from the UK government, overseas governments, and other kind of major public organisations. We don't do much consultancy as such. And we've got three main challenges that BGS works on: hazard and risk, environmental change, and then decarbonisation and resource management. And of course, that third challenge is what we're really talking about here today. And this diagram, which is a bit detailed for those screens, this just shows all the aspects of decarbonisation and resource management that BGS works on. And lots of things we've heard about today: carbon capture and storage of nuclear waste, citing marine renewables, geothermal energy, and of course, critical minerals. And I'm going to talk mostly about critical minerals now and just give you a summary of some of what we're doing at the moment. So BGS Minerals team kind of covers three main areas, if you like, in the field of minerals. First of all, we provide mineral statistics, particularly production information for almost all commodities and almost all countries. So almost all commodities that are mined. And our mineral stats data sets have been running more than 100 years. So it's a real wealth of information of how things have changed over time. Then we do a load of research, which is focused on critical minerals, both in the UK and worldwide. A lot of that is funded by research grants, so is a bit more on the sort of academic side, but some of it is also funded by government. We have a particular focus at the minute on lithium and the rare earth elements. That's my favourite commodities. I'm leading a big research project on lithium at the moment. I'm not going to talk much about that, but anyone wants to talk about spodumene pegmatites, I'm very keen on that. And also on cobalt and nickel. We have other projects on those. And we have really significant analytical lab facilities. I'm even going to show you the outputs of one of those lab facilities in a moment. And then thirdly, we have another real research strand on supply chains. So we're not just all geologists looking at the rocks. We also have a lot of work on the whole supply chain, understanding stocks and flows of commodities, and analysing the interactions between those mineral resources, the economy, the environment, and society. And then we have the Critical Minerals Intelligence Centre, and I'm going to come to that in a moment. So first of all, critical minerals, we heard earlier on the importance of critical minerals, that they are those that are critical for the economy, but also have some risks to supply. And of course, the thing that's made them so interesting now, and we've heard a lot about this today, is, as this is shown from the International Energy Agency, the amount of minerals that we are going to need for the energy transition. So that nice diagram on the top shows you the difference in the amount of minerals required between an electric vehicle and a conventional internal combustion engine vehicle. It's a huge difference. And I think somebody said earlier on, copper is boring. Copper is definitely not boring. Copper is, of course, essential in all of this. We're going to need huge amounts of copper. It's not listed as critical currently because we get copper from so many different places around the world. But many people looking at criticality assessments are talking about copper and how important it is. And it may well be that it will be on some critical lists soon. Looking again at the lower part of that diagram, obviously again for clean energy technologies, the amount of minerals we're going to need is much more significant than we needed for fossil fuel power stations. So we're looking at the requirements for minerals really increasing, but something that we always try and remind people is still the critical minerals that we talk about are a very small part of all the minerals that we need to mine. Indeed, on the left, that bar shows you all the minerals, all the metals and ores that were mined. These are, I think, 2021 figures. And you can see that iron ore, of course used for steel, dwarfs everything. And then we start going down, we come to things like aluminium, manganese, copper. By the time we get down to lithium, and as I said, these figures are a little bit out of date, we're looking at only about 100,000 tonnes a year. That is, of course, increasing. But we are still talking about quite small markets for these critical minerals, and so we should never forget those major metals that are obviously so important. But again, going back to the International Energy Agency and their 2021 report, of course, those markets are growing. And we're looking at, I'm not sure whether lithium demand is really going to increase 42 times by 2040. That I have always thought that seems unlikely, but I like to put this figure up because it's so kind of indicative of the ideas. But we saw earlier on the range of possible increases in demand and the challenges, of course, in forecasting those increases in demand. There is no doubt the battery raw materials and many other critical minerals we're going to see significant demand increases. And so that means that security of supply of minerals is a UK government priority. We just heard maybe geothermal isn't being viewed in quite the same priority way, but critical minerals over the last few years have become really important for the UK government. We've seen the net zero strategy that mentioned critical minerals. We've seen the development of a critical minerals expert committee, and then we've seen a UK critical minerals strategy, and we've seen a refresh of that strategy already this year. And as part of that strategy, the Department for Business and Trade committed to establishing a critical minerals intelligence centre. And we are hosting that centre at BGS, and you may well have already seen many of the products of that intelligence centre, which I'll talk about as CMIC, just easier. So the CMIC is based at BGS, and its aims are broadly to support the UK in securing those sustainable critical mineral supply chains to ensure, of course, as we've heard, the success of the net zero transition. And most of what CMIC is about is providing some of that data, information and analysis on stocks and flows of critical minerals to the UK government. And you can go to ukcmic.org and have a look at a lot of the information that is being provided. But I'm not going to go into most of that in too much detail because I want to focus in on maybe what's a bit more relevant right now for the North East. So let's go to the UK critical minerals list. And this was done in 2021. And this is a criticality assessment like so many that have been done. It looks at the importance of any particular commodity to the UK economy and then looks at the risks to supply for that. Now, this really represents a snapshot in time that's very important to think about. So in this diagram, we see the rare earth elements up there as being the most important to the UK economy and also the most risk to supply. Those risks to supply, of course, are because most rare earth elements are both mined and refined in China. And we see a range of other elements and minerals shown as having different levels of criticality. You can perhaps see in there that lithium almost doesn't fall into the high criticality quadrant at all. Now, we heard earlier on about potential changes in demand. For example, if rare earth magnets start being replaced by magnets that require strontium, barium, and iron. Now, interestingly, at the moment, strontium is seen as being pretty low in importance to the UK economy. Barite isn't even on this figure. And obviously, if we have that sort of change in demand, we're going to see changes in which minerals are seen as critical for the UK. And another thing that can have a real effect, of course, is changes in supply. In the last few months, China has decided to start controlling the export of gallium and germanium. And these are really important for semiconductors and actually may well be very important for the UK economy. And this has just started to have an effect. Just in August, Chinese exports of these elements dropped to zero. So we're now going to have to look at where those may move to, if you like, on that criticality matrix. BGS is doing a foresight study right now to try and get a bit of a better picture of those sorts of changes, those anticipated changes in levels of criticality of these minerals. So then the big question, is there potential for us to produce some of these critical minerals in the UK? And of course, we've been talking about lithium today. There are lithium resources already established in Cornwall, and there's a lot of investigation of lithium here, as we've heard about. But a really important point is that the UK was a mining country. The Romans didn't come here for the wine or for the weather. They came for the metals. And that historic mining has included a range of commodities such as tin, copper, lead, zinc in this area, in the North Pennines ore field, tungsten, gold and silver. What do we mine currently? Well, we do have some gold mining. Fertilizer minerals, of course. We heard about bulbi, which I'm very envious. I've never been into bulbi. I'd love to go. We have silica sand being mined, some fluorspar. And contrary to what we heard earlier from one speaker, barite is in fact mined in the UK. So we do have some mining, but it is limited at the moment. But we've got many mines and exploration projects, not just lithium, but things like tungsten, copper, nickel and gold are all being explored in the UK at the moment. Now, this diagram on the right shows you the kind of wheel of, if you have a major commodity, what might be produced as a byproduct. Most critical minerals are produced as byproducts. And for example, if you're producing zinc, then you might be able to produce as byproducts the germanium and gallium that we know may be increasing in criticality because China is not currently exporting them to us. So you have to think, when you're thinking about domestic critical mineral production, not just about, are we going to mine lithium, but also, are we potentially going to mine copper or zinc, and what could we produce as byproducts? And the sort of overarching answer to my question is yes, there is potential. And one thing that we've done recently is a really high-level assessment of UK prospectivity for critical minerals. And we did this using the data that, of course, BGS holds with the National Geoscience Data Centre. We went back to the existing geological maps, the geochemical maps, I'll come to those in a moment, to the existing borehole data, to the knowledge about what's been mined in the past and where exploration is going on now. And we also used our understanding of the geology, so we did a simplistic, what you call a mineral systems analysis. And this was done not by clever modelling. The data's not really good enough for that across the whole UK, but done more by geologists assessing, well, knowing what we know about the mineral systems and where you might expect to find these critical minerals in terms of the geology, what can we say about the areas that are potentially prospective? And there is a report that you can look up on the CMIC website, but this map here just shows the maps we generated for all the different critical minerals overlaying on top of each other. So where you see relatively dark green, you can see areas that we consider as being potentially prospective for critical minerals. Now, most of these areas come as no surprise because, in general, they are historic mining areas. But we identified, I think it's a list of 8 key areas, and you can see that they are spread across Scotland, Northern England, Wales, Southwest England, and Northern Ireland. So there's many areas, and of course the North Pennine Orefield is one of those areas. And this is going to underpin a programme of new survey and research on UK critical mineral resources. Although that's something that we don't have vast amounts of funding to do, so it's not going to happen at great speed. So apologies if you were hoping for loads of data coming out every year, that's probably not going to happen. But we are working on it, and I'm just going to show you a couple of the things that we are working on. But firstly, I said I was going to talk about the geochemistry. And these are really interesting data sets. So one thing that we have done on that UK CMIC website, you can look at the existing National Stream Sediment Survey data. So this is a really systematic survey that's been done by collecting stream sediments all across the UK and analysing those for a range of different elements. And we replotted those data so that they would really pick out anomalies of some of the critical minerals or the critical elements. So what I'm showing you just now is rubidium. And rubidium is interesting because it should highlight the granites that are, if you like, the hot granites that we've heard talked about already that are of interest for deep geothermal, but also the granites that are associated with potential lithium deposits. And you can see pretty clearly there's 2 areas that are red, high rubidium. That's the granites in southwest England and the granites in and around the Cairngorms. There's a decentish blob around Treviot, but of course we can't see the Weardale granite on there because it's buried beneath the surface. So then we would like to compare this with lithium. Can we actually see evidence of lithium, areas of interest for lithium in these stream sediments? And we only have lithium data. Many of you will know lithium is not the easiest thing to analyse in the world. We only have lithium data for part of the country. But I think this is really interesting. Again, those hot red areas are the areas where the stream sediments have most lithium in. Now, we were expecting those Cairngorm granites to be pretty hot, pretty red. They're not. Those anomalies, you can see where they are. They are in the northern part of the Lake District, and then they are in the area around the North Pennine Orefield. Those lithium anomalies are in sedimentary rocks. Now, Seb, you said earlier, lithium is produced either from brines or from hard rocks. And that is right in terms of production of lithium. But there is a third type of lithium deposit that is just being explored worldwide and is not producing anywhere yet. And that's the lithium clays. There's something interesting here, which we will hopefully follow up. But yeah, these data are really useful and interesting. I would recommend having a look at them. And there is definitely something to think about there in the North Pennines and what is happening with those lithium anomalies in the stream sediments. I'm not going to say any more about that because I literally only spotted this when I was putting this talk together yesterday. So yeah, interesting. Now, ongoing research in critical minerals in North East England. Don't even try to look at this in any great detail. My point here is that we are thinking about some very detailed kind of research. I said, if you were looking for zinc, might you be able to look for gallium and germanium? How many analyses do you think are out there in the North Pennines Orefield of gallium and germanium in samples from historic mines? Not a lot. Yeah. Essentially, many of these critical minerals are things we couldn't even analyse for until relatively recently. So we know that there is potential for areas that have been mined for lead and zinc to also host a number of different critical minerals. We don't have that information. So, for example, these images, which I know you can't see very well, they just illustrate a piece of work we've been doing looking at some of the ore samples from just some spoil heaps from within the North Pennines ore field. These ones are from Lady's Rake mine. And just looking at, does sphalerite, that's a zinc ore, have enrichments in things like gallium and germanium? The spoiler is that yes, it does. So interesting, but there's a lot more to be done in terms of systematic data gathering. But that's the kind of thing that we're doing. This is the kind of thing that is BGS's job. Not many companies are going to start doing this sort of work, but if we do it, the data can be made available. Similarly, we are working on some prospectivity modelling. We had a lot of thought about which area should we start on doing some machine learning driven type prospectivity modelling in the UK. And we did decide that the North Pennines was the best area to do that. So we are working on some prospectivity modelling, and that will tie more to some of these other critical minerals like gallium, germanium, etc. Harder to do that for lithium because still don't know where the lithium is in terms of the rocks. But maybe we'll come to that. So that's me kind of more or less wrapped up in terms of critical minerals and what's going on in the UK. As I said, I've got a few geothermal slides, but you will recognise most of them. So this one is really just highlighting what Jason has already said. And these are from my colleague, Alison Monaghan, who's our head of geothermal. Just highlighting the importance of the less high temperature, more shallow mine water, ground source heat pumps, the mid-depth sedimentary basins, and the deeper and hotter granites. And exactly the point that Jason made, geothermal is about all these different things and a mix of using those different technologies. And again, you've already seen this map, and it highlights the potential in Northeast England for geothermal. But the really important point here again is that BGS is about making data and maps and models available to inform the sort of work that is going on developing more detailed, specific geothermal projects. And again, you've seen this, and it's just a reminder of the geothermal research that is going on. There is work on granites in Cornwall, and indeed, that ties together the critical minerals, the potential for lithium, with potential for geothermal power and heat. There's research, as you heard from Jason, on regional distributions of sedimentary aquifers and where there is potential for geothermal. And there's research on mine water geothermal, lots of collaborations there. So really, just to wrap up my conclusions, BGS is the National Geoscience Data Centre. We have a huge amount of data. We acquire some new data, but we can also make a lot of use of what we already have. And that allows us to understand potential on a national or regional scale for critical mineral and geothermal prospectivity. We're not the ones that are going in there and looking at individual locations and trying to understand the detail at a site level, but we are there to provide the regional scale data. And our data is typically openly available through reports or online or by accessing our National Geoscience Data Centre, and all underpins our impartial advice to government. And some of the work we've done recently does recognise that North East England is really important for both critical minerals and geothermal. So this is certainly an area where the BGS is going to be carrying on working and hopefully collaborating with all of you. Thank you.